Hello, my dear students. Today we are going to present the chemistry program for General Secondary Certificate. We are going to start with the first chapter, which is the transition elements. And today we are going to start with the general revision on the periodic table, and then we are going to discuss the first transition series, and we are going to discuss the economic importance and uses of the first transition series. So let us start. Transition elements. We are going to start with the revision along form periodic table. The periodic table consists of 18 vertical groups and 7 horizontal periods. The elements of the same group have same valence electrons, so have similar chemical properties. The elements of the same period have the same number of energy levels. Now we are going to discuss the blocks of the elements in the periodic table. In the left side of the table, we see the S block elements. These elements, their electronic configuration, end by filling the S sublevel. On the right side of the periodic table, the elements configuration end with the sublevel B, and so we call them B block elements. In the middle of the periodic table, we find the elements that their electronic configuration end by filling the D sublevel, and we call them D block elements. And below the periodic table, we find the element that their electronic configuration end by filling the F sublevel. As shown on the screen, these are the elements of S block in the left side, and on the right side the elements end by B sublevel, and in the middle the elements that end by D sublevel as electronic configuration and these elements, and below the table the elements that their electronic configuration end by filling the F sublevel. Now we are going to discuss the types of elements. The elements where electronic configuration end by filling Ns1 and 2 electrons and Nb from 1 till 5 electrons, where N is the number of the principal energy levels in the atom. These elements are called representative elements or main group elements. And the elements that their electronic configuration end by filling the B sublevel, that contains 6 electrons, and helium, which has electronic configuration 1s2, these elements are called inert gases. And my dear students, the elements where their electronic configuration end by filling the D sublevel from 1 till 10 electrons and the F sublevel from 1 till 14 electrons, they are called transition elements. So, my dear student, we have two types of the transition elements. They are the main transition elements and inner transition elements. My dear student, notice that the transition elements includes more than 60 elements, which are more than half the number of the known elements of the periodic table. As shown on the screen, these elements of S and B block are called representative elements, but the end of the B block that have electrons contain 6 electrons in the B sublevel and helium 1s2 are called noble elements, and the elements in the middle of the periodic table are called main transition elements, and the elements below the table that end by filling the F sublevel called inner transition elements. Today we are going to discuss the main transition elements. These elements, the outermost electrons, are filled in the sublevel Nd, where N is from 3 to 6, which is the number of energy levels inside the atom. As shown on the screen, we have 4 series that elements end by filling 3d and 4d and 5d and 6d from 1 till 10 electrons. Since the d sublevel is filled by 10 electrons, so the d block contains 10 columns. These columns start from the first column, which contain elements which their electronic configuration end with ns2 n-1d1, to the last one, which ends with electronic configuration ns2 n-1d10, in which the d sublevel is filled in the sequence as shown on the screen: 4s2, then 3d from 1 till 10, then 5s, and then 4d from 1 till 10, and 6s2, 5d, 1 till 10. And my dear student, remember that the 4f sublevel is found between 6s and 5d, and is filled after filling the 5d1, then complete the f sublevel, and then continue filling d sublevel. And also in the last period, 7s2 and 6d1 till 10, here, my dear student, the 5f sublevel is filled between the 6d1 and then 5f is completed, then d continue to filling it till 10 electrons. Now we are going to discuss the groups of the main transition elements. There are 7 columns belong to B groups, and the other 3 belong to group 8. So the groups are 3b, that filling D sublevel with 1 electron, then 4b, 5b, 6b, 7b, and 3 columns for group 8, and 1b and 2b. These groups fill the D sublevel by 10 electrons. As shown on the screen, the group 3b end by filling the D sublevel with 1, and the group 4b end by filling the D sublevel by 2, and 5b end by filling the D sublevel by 3 electron, and chromium, the D sublevel contain 4, and we have abnormal configuration for it, and we are going to discuss it later. And then manganese filled by filling the D sublevel with 5 electrons, and then iron and cobalt and nickel group 8, that filling the D sublevel by 6, 7, and 8, and the copper that have electrons in the D sublevel 9 but has abnormal configuration, and we are going to discuss it later. And then zinc that contain 10 electrons in the group 2b. Here these D block elements in period 4, 5, 6, and 7. We have given reason in this point. Group 8 contains 3 columns. The reason for that is the similarities between the horizontal elements of these 3 columns are more than the similarities between the vertical elements. Now, my dear students, the main transition elements are classified to the number of the outer energy level and according to the period, giving 4 series, which are: first transition series. These first transition series include the elements from scandium till zinc, and the outermost electrons are filled in the 3d sublevel, and they are in the 4th period, and the elements are from scandium till zinc, with atomic numbers 21 for scandium and 30 for zinc. The second transition series. My dear student, these elements have the outermost electrons filled in the 4D sublevel. They are found in the fifth period of the periodic table, and these elements start from deuterium and end by cadmium. The third transition series. This third transition series have outermost electrons are in the 5D sublevel, and they are in the 6th period, and these elements start from lanthanum and end by mercury. The fourth transition series. My dear student, these elements have the outermost electrons filled in the 6D sublevel, and they are found in the 7th period. My dear students, today we are going to discuss the first transition series in details. We are going to discuss first the weight percentage of this element in the Earth's crust. The scandium, as shown on the screen, 0.0026%, and titanium 0.66%, and vanadium 0.02%, and chromium 0.014%, and manganese 0.11%, and iron 6.3%, and cobalt 0.03%, and nickel 0.0089%, and copper 0.0068%, and zinc 0.0078%. So, as shown on the screen, iron has the greatest percentage of this element in the Earth's crust. And this first transition series form less than 7% of the weight of the Earth's crust, and they are located in the 4th period, and their outermost electrons are filled in the 3D sublevel. Now, my dear students, we are going to discuss the properties and the economic importance of these elements. The first element we are going to discuss is scandium. This element is rarely found in the Earth's crust. So, my dear student, be careful, that can be question or scientific term. The element which is rarely found in the Earth's crust, you have to answer by scandium. And we have give reason for another property. Its alloy with aluminum is used in make fighter jets. The reason for that, it is less dense and hard. Another point and another property have give reason also that the scandium is used in the TV photography at night, because it is added to mercury vapor lamps to produce light, which is strong light. Now we are going to discuss the titanium. This element is a strong element with rigidity as steel but less dense, and its alloy with aluminum is used in the space shuttle and aircraft, and we have give reason for this point, because it maintains its durability at high temperature while hardness of aluminum decreases. Another property and use for the titanium is used in the dental implants and artificial joints, and we have give reason for this point, because it is inert substance, so the body doesn't eject it and doesn't cause any type of poisoning. The another property is that titanium dioxide TiO2, or we can say titanium 4 oxide, as the valency of titanium here is 4, is used in some protection cosmetics, and we have give reason for this point. Because its nanoparticles prevent reaching of ultraviolet rays to the skin. The next element, which is vanadium. The vanadium steel alloy is used in car spring, and we have give reason for this point. Because vanadium gives the steel hardness and corrosion resistance. Another use and property for vanadium, its oxide, vanadium pentoxide, is used in 3 different uses: manufacture of dyes used in ceramic and the glass industry, and it is used as catalyst in the industry of sulfuric acid by contact process, and the third one in the manufacture of strong magnetic conductor. The next element, which is chromium. The chromium, my dear student, is highly reactive, but it resists the effect of air, and we have give reason for this point. The reason of it is due to formation of non-porous layer of the chromium oxide, where its molecules are larger in size than the metal molecules themselves, that prevent further reaction with the air, and this is called passivity of chromium. My dear student, this passivity protects the element from further oxidation. Another use for chromium, it is used in plating metals and laser tanning. My dear student, we have a compound for chromium, which is oxidizing agent, is called potassium dichromate, that has chemical formula K2Cr2O7, that used as oxidizing agent. And another compound for chromium, which is chromium oxide, that is used in the manufacture of dyes. Remember, my dear student, we have now 2 compounds, 2 oxides for the dyeing manufacture: chromium oxide and vanadium pentoxide. And we have 2 oxidizing agents that we have discussed, that manganese, we are going to discuss it, and potassium dichromate as oxidizing agent, and the manganese dioxide also oxidizing agent. So we are going to discuss manganese. The manganese as its element is not used as a pure element because it is brittle, but it can be used in form of alloys or compounds that I explain here. The ferromanganese alloy used in railway track because it is harder than steel, and its alloy with aluminum used in the manufacture of can because it resists corrosion. Manganese dioxide also is used as a strong oxidizing agent in dry cells, and potassium permanganate is used as oxidizing agent and as antiseptic. So my dear student, to study these properties, you have to collect the oxides to keep their properties for these different elements, and use the compounds that can be used as oxidizing agent or dyeing to keep these properties easily. Next property for manganese, the manganese compound, which is manganese sulfate, is used as fungicide. Iron, this element is used in the reinforcing in concrete, this reinforced concrete used in engineering, and the electricity pylons and knives and pipes, guns, cannons, and surgical tools. So it can be used for different fields: the engineering and medicine and military application. Iron, it can be used as catalyst for industrial preparation of ammonia by process called Haber-Bosch process. And also it can be used as catalyst to convert the water gas, which is a mixture of hydrogen and carbon monoxide, to liquid hydrocarbon fuel by process called Fischer-Tropsch process. Cobalt. The element cobalt is used in the manufacture of magnet. The reason for that because it can be magnetized as iron. Also, cobalt is used in the manufacture of modern dry batteries that used in cars. Cobalt has 12 radioactive isotopes. The most common isotope for cobalt, 60, is used in the preservation of food. Also can be used for detection of quality of industrial products and detecting cracks and welding connection. The reason for that because it emits gamma rays which have high penetrating power. Also, it is used in medicine as detecting and treating tumors. Now we are going to discuss nickel. Nickel is used in the manufacture of nickel-cadmium battery that can be recharged. My dear students, we are going to discuss in chapter 4 the batteries that can be recharged. We call them secondary cells. We are going to discuss them in details later. Now, the nickel can be used as alloy with steel, which characterized by hardness and resist rust and the effect of acids. The alloy of nickel and chromium used in the manufacture of heating coil and the electric furnace. And the reason for that, it resists corrosion when they are heated to red hot degree. Also, nickel is used in bending metals. The reason for that because it gives better appearance and also resists the rust. And the finally divided nickel is used as catalyst in hydrogenation of oil to produce fats that we call artificial fats. And we are going to discuss it later in the chapter 5 of organic chemistry. And copper. The copper is the first discovered element. And the alloy of copper with tin is called bronze. So my dear student, maybe question, scientific term, the first discovered metal, you have to say copper. Here, my dear student, the alloy of copper with tin is called bronze. Copper is used in the electric wires and equipments. The reason for that because it has high electric conductivity. Also, it is used in the manufacture of coin alloys. My dear student, the copper sulfate compound is used as insecticide and fungicide in purifying drinking water. My dear student, Fehling solution, which is copper compound, is used to detect glucose sugar because its color it changes from blue to orange. Now we are going to discuss zinc. It is used in galvanizing metals by covering the elements or metals by zinc. We call it galvanization. The reason for that to protect them from rust. Now zinc oxide is used in the manufacture of paints, rubber and cosmetics. And zinc is also used in zinc sulfide, which is used in the manufacture of illuminating paints and X-ray screens. Now we are going to discuss questions. The first type of question is choose the correct answer. The element in which the outer levels have the electronic configuration 5F14, 6D6, 7S2 is from what type of transition series? My dear student, in order to answer this question, you have to look at the D sublevel here. It's not completely filled yet. But here, the 6D find is completed after 5F. So we will find the answer. If you are going to choose between these choices, first or fourth or second or inner lanthanide, if you think about the answer, you will find that the answer is the element in which its outer level have the electronic configuration 5F, 6D, 6, 7S2 is from fourth transition series. It is from main transition element in the fourth transition series. Next point, the element in which the outer levels have the electronic configuration 4F14, 5D2, 6S2 is from what type of transition series? Is it third, inner actinides, second, or inner lanthanide? If you think about it, my dear student, you will find it is from the main transition elements, and it will be from the third transition series, as filling the D sublevel. Next point, element which is strong as steel but less dense than it. Is it scandium, titanium, iron, and zinc? If you think about it, here is the answer. It will be titanium. Next point, element which we use in plating metals and leather tanning is what? Is it scandium, chromium, iron, and zinc? If you think about it, yes, it will be chromium. Next point, element which is rarely found in the Earth's crust. Is it cobalt, scandium, iron, zinc? If you think about it, yes, it will be scandium. Next point, element which we use in TV photography at night. Is it titanium, scandium, iron, zinc? If you think about it, yes, it will be scandium. Next point, element which is highly reactive but resist the effect of air. Is it scandium, chromium, iron, zinc? Yes, the answer it will be chromium. I know, my dear students, you know the answer due to its passivity. Next point, element which is used in the reinforced concrete and electricity pylons. Is it scandium, iron, chromium, zinc? If you think about it, yes, it will be iron. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.